Hi everyone, welcome to video 3.5 where we're going to look at symbolic arguments. So I have two arguments here. We're going to call each one a premise. So premise one is if we go to the Bahamas, then we will go snorkeling. And premise two is we go to the Bahamas. What logical conclusion can you draw from those two statements? So if you said we will go snorkeling, you are correct. Premise one implies that if we go to the Bahamas, then we will go snorkeling. So if P, then Q. We go to the Bahamas. That's P. So if P, then Q, P occurs. Therefore, Q will occur. The consequent. So we will go snorkeling. What we're going to focus on in this section is determining the validity, so how valid or truthful an argument is. In the previous sections, we used symbolic logic to determine the truth value of a compound statement. Remember, compound statements are just simple statements that have ands and ors and if-thens and if and only ifs. In this section, we will extend those ideas to determine whether we can draw logical conclusions from a given set of statements. So as you just saw above, a symbolic argument consists of premises and a conclusion. An argument is valid when its conclusion necessarily follows from a given set of premises. An argument is invalid, which is also called a fallacy, when the conclusion does not necessarily follow from the given set of premises. Was the argument above a valid argument? Why or why not? So feel free to pause the video and then unpause when you're ready to find out the answer. The argument above is valid because the conclusion follows from the premises. So how do we exactly determine if an argument is valid or invalid? One of the easiest things to do is first write the argument in symbolic form. Then we're going to construct a truth table, and as long as the answer column is all truths, the statement is a tautology and the argument is valid. So remember, we talked about the word tautology in one of the previous sections, and tautologies are just statements where the truth value in the answer column, it's all truths. If the answer column does not have all truths, the argument is invalid. So let's look at the following statements and see whether we can determine if they're valid or invalid. So my first statement says, if the marsupial is taller than 1 meter, then the marsupial is a kangaroo. The marsupial is taller than 1 meter. So first of all, what can you conclude from that argument? Premise one and premise two, you would conclude that the marsupial is a kangaroo. So now, we're going to determine whether that's valid or not. So P is going to be the first part of the statement. So P would just say the marsupial is taller than 1 meter. And Q would state that the marsupial is a kangaroo. So this says, if P, then Q. What occurred? The marsupial is taller than 1 meter. That would be P. So if P, then Q, P follows. Therefore, Q should follow. And Q is our conclusion. The marsupial is a kangaroo. So this is known as the law of detachment. And it is a valid argument. We would expect that if the marsupial is taller than 1 meter, then it's a kangaroo. The marsupial is taller than 1 meter, so therefore we would conclude that it is a kangaroo. That is a valid argument. Let's take a look at the next one. If Detroit is in Michigan, then Dallas is in California. Dallas is not in California, so my conclusion is, therefore, Detroit is not in Michigan. So the first thing I'm going to do is write out my symbols. So for P, it's the first part of the statement, which would be Detroit is in Michigan. And Q is the second part, which is Dallas is in California. So let's write this in symbols. If Detroit is in Michigan, then Dallas is in California. Dallas is not in California, so not California would be not Q. What can we conclude now? Therefore, if Dallas is not in California, then it would be assumed that Detroit is not in Michigan. Is the argument valid? Yes. You can make a truth table to determine. This is known as the Law of Contraposition. So if you'll recall from chapter 2, remember when you had a statement, a conditional if P then Q, the contrapositive was equivalent to it. What did the contrapositive say? It said, if not Q, then not P. So if you compare, you've got your if P then Q, and then you also have your contrapositive, if not Q, then not P. This is known as the law of contraposition, and it's a valid argument. Try letter C and then unpause when you're ready to check your answer. In letter C, we have the grass is green or the grass is full of weeds. The grass is not green, therefore the grass is full of weeds. So first define P and Q. So the grass is green, and we have an or. So this is P or Q. The grass is full of weeds. Premise 2 is the grass is not green. So not P. What can I conclude? I can conclude Q. This is known as a tautology. And if you made a truth table, you would see that you would have all truths for your conclusion. This is a valid argument. And it's also known as a disjunctive syllogism. Which you can see here. So in this table, I have listed all the standard forms of arguments, and we have gone through each one of them except for the law of syllogism. So now remember, since this is an or statement, P or Q, only one of them has to be true for it to be true. So if I say if P or Q, then not P, therefore Q, Q is true. So therefore it's a valid argument. Using the chart I just showed you, we can determine whether an argument is valid or invalid without making a truth table. All we need to do is identify the argument as one of the standard arguments in the chart. So let's compare the examples to the arguments above and see if they're valid or invalid. In my first example, it says, if you are on Instagram, then you see my pictures. If you see my pictures, then you know I have a cat. Therefore, if you are on Instagram, then you know I have a cat. So the first statement, if you are on Instagram, anywhere I have Instagram, that's going to be P. My second statement, you see pictures, that's going to be Q. And then the third statement, you know I have a cat, is going to be R. So if you are on Instagram, then you see my pictures. So if P, then Q. If you see my pictures, then you know I have a cat. So if Q, then R. Therefore, my conclusion says, if you are on Instagram, so if P, then you know I have a cat. If R, then R. See if you can find that example in the table that's posted above. If you recognize it as the law of syllogism, you would be correct. So that's a valid argument. And I want you to make a little note here. A syllogism is just another form of an argument. For A and B, we're going to determine the same thing, whether the arguments are valid or invalid. So please pause the video, try A and B on your own, and then unpause when you're ready to check your answer. In letter A, it says, if it is snowing, then we put salt on the driveway. So if P, then Q. We put salt on the driveway, which is Q. Therefore, it is snowing, P. Is that valid or invalid? If you said invalid, you're correct, because just because we fulfilled Q doesn't mean we did the previous part, the if. So this is invalid. And it's known as the fallacy of the converse. If you recall from the last section, if you have a conditional if P then Q, the converse of that is if Q then P. Those two statements are not equal to each other. So that's an invalid argument. That would be like saying our original example when we first started this section. If we go to the Bahamas, then we go snorkeling. And then it's like saying, okay, we went snorkeling. That doesn't mean we went to the Bahamas. If we went to the Bahamas, then we go snorkeling. And the last example is, if it is snowing, then we put salt on the driveway. It is not snowing. Therefore, we do not put salt on the driveway. So if I convert this, the first conditional statement is going to be if P then Q. It's not snowing. That's not P. Therefore, what's my conclusion? Not Q. If you said this is an invalid argument, you would also be correct. This is known as the fallacy of the inverse. So if you recognize here, in the last section, we did if P then Q. What was the inverse? It was negating the P and the Q. And those two statements were also not equal. So you can recognize that here, that that's an invalid argument. And when you look in the chart, you can see the fallacy of the inverse right here. And in the last example, we had the fallacy of the converse. That's the end of section 3.5. After you've taken the notes and you've watched the video as many times as you need to, please feel free to start on the assignment. If you have any questions, please email me. or contact me during my office hours. Okay, guys, I hope you all have a great rest of your day.